Hello everyone, I'm Shalaka Deshpande. Welcome to my YouTube channel. Today's topic is a watchdog timer and why it is used in embedded system. So let's get started with the today's topic. Okay, so the first point is our desktop Windows system. Now all of you must be having the laptops, PCs in your houses. So in the desktop Windows system, whenever the system malfunctions or whenever the system gets hanged, you press Ctrl plus Alt plus Delete to come out of the situation. So whenever your computer gets hanged, you press Ctrl plus Alt plus Delete to get out of the situation. But have you ever wondered about the embedded system? What if the embedded system there is any problem or malfunctioning, or what will happen if the embedded system gets hanged? If the embedded systems get hanged, we have a solution, and that is a watchdog timer. Now, what are your embedded systems? Embedded systems like your AC, microwave oven, washing machine. These are your embedded systems. And whenever there is a hang or malfunctioning in the embedded systems, those embedded systems are having watchdog timer. Now, what does the watchdog timer do? See, the watchdog timer monitors the firmware execution. Okay, whatever the execution of code is there, it is monitoring that execution of code. It monitors the firmware execution and then it resets the processor, and if there is any problem in the embedded system, it resets the corresponding processor or a controller, and after resetting the processor or controller, it remains reset till the operation becomes normal. Okay, fine. Now next, now what are the contents of this watchdog timer? Watchdog timer is having free running counter and watchdog timer register. Watchdog timer is having two contents. First is the free running counter. It is having one free running counter and a watchdog timer register. Okay, these are the contents of the watchdog timer. Okay, now next we will see the working of the watchdog timer. How does the watchdog timer work? Now in this diagram on the right hand side, there is one watchdog timer and there is one microprocessor or microcontroller which is connected with the watchdog timer. Okay, now what does the watchdog timer do? You can see this free running counter inside the watchdog timer. This watchdog timer free running counter is set to 0, okay, by the software. Okay, when this free running counter is enabled, it is set to 0 by the software, and when the clock pulses are provided, it starts counting. Okay, and it starts counting, watchdog timer starts counting before start of execution of the code. Means simultaneously after a code start executing, it is executing in its place, and at the same time watchdog timer counter is also incrementing the count by 1 as we are providing it the clock pulses. Now suppose because of the malfunction or some problem, the code is not able to finish, the task is not getting completed because of the malfunction, and watchdog timer count is expired before completion of the code, completion of the program task. Then what will happen? See, in this case the watchdog timer will reset the microprocessor or microcontroller via this reset signal line. You can see the signal line connecting the reset pin of the microprocessor or microcontroller. This watchdog timer resets the microprocessor or microcontroller when it gets expired before completion of the execution of the code. And in the second case, if the watchdog timer gets expired before, before means code is getting executed, and before that execution, if the watchdog timer is expired, what will happen? Now in before, what is happening? There is some defect, malfunction in this embedded hardware. Okay, so watchdog timer is expired before the completion of a code, but if the code gets completed and watchdog timer is not expired. Okay, if the code gets completed, function of the system is over and watchdog timer is still counting, it is not expired, then we have to reset the watchdog timer register by writing 0 to it, and in this way the watchdog timer works. And this watchdog timer is mostly the built-in component of most of the microprocessor and the microcontrollers. Okay, it is built in. Okay, So in this way, you just have to remember, whenever there is a malfunction or some abnormality or any problem, or if the embedded system hangs in a particular situation, then Watchdog Timer resets the microprocessor or a controller concerned with that embedded system. Okay, so this was about the Watchdog Timer working. Okay, now let's see the modern system with the embedded operating system. See, now there are some modern embedded system with the embedded OS. Okay, so is this the same case in them? In the modern embedded system, the Watchdog Timer is not resetting. I repeat, the Watchdog Timer does not reset the processor or a controller. It sends interrupt when the Watchdog timeout expires. When the Watchdog timer expires, it sends interrupt to the processor and controller, and interrupt handler handles the situation. Okay, so in the modern embedded systems, we have interrupts for Watchdog timer reset. Okay, for Watchdog timer reset is not present. Okay. And now there are two types of Watchdog timer. Two types of Watchdog timer are up counting Watchdog timer and down counting Watchdog timer. In up counting Watchdog timer, when the clock pulses are provided to this free running counter, when the clock pulses, see here, this is a system clock pulses are provided to this free running counter, it starts count from 0, 1, 2, 3, 4, 5 and so on, up counting. And second is a down counting Watchdog timer. In the down counting Watchdog timer, when the clock pulses are sent to the free running counter, it starts decrementing the counter from 100, 99, 98, 97, 96. So this was about the Watchdog timer. I hope you have understood this topic and enjoyed this video. So please like, share and subscribe my channel. Thank you for watching.